As we continue in our fraction unit, our next lesson is on multiplying fractions. The concepts we have already covered in this unit are reviewing fraction vocabulary, such as numerator, denominator, common denominator, converting fractions between improper fractions to mixed numbers, finding common denominators once we have recognized what they are, and adding and subtracting fractions. These are all skills that are necessary in order to continue. Let's just do a quick review on how to add fractions. First of all, we notice that the denominators are different. In order to add fractions, we have to have common denominators. So looking at the 4 and the 2, we need to find something, a number, that they both go into. Usually you can start with the larger number, and that would be the easiest direction to go. So I'm going to keep my 4, and I'll ask myself, how do I get from 2 to 4 by multiplying? I know that 2 times 2 equals 4. And whatever you do to the top, you do to the bottom. 2 times 2 equals 4, so I do the same thing to the top. 1 times 2 equals 2. 1/2 now became 2/4. Since I'm keeping the same denominator, my numerator also stays the same. So I have my new problem. 1/4 plus 2/4 equals 3/4. It's quite simple after you have figured out the common denominators. We have had many opportunities in the past couple of lessons to practice this type of problem. Subtracting fractions is the same process as addition. You find common denominators and then you subtract. So looking at the denominators, I have a 6 and a 3. So again, I'll start with the larger number 6 and try to make that work. I ask myself, can 3 go into 6? And it does, 2 times. So I take both the top and the bottom times 2. 3 times 2 equals 6. 1 times 2 equals 2. Again, since I moved the 6 over, I also move the 5 over. My new problem, 5/6 minus 2/6 equals 3/6. Now that we have done a quick review on how to add and subtract fractions, we can move on to multiplying fractions. And I think you will be pleasantly surprised to see that multiplying fractions is quite a bit easier. For once, you do not have to find common denominators. When I have two simple fractions, like you see here, all you have to do is multiply across. 1 times 1 equals 1, so that's my new numerator. 4 times 2 equals 8. That's my new denominator. A problem like this is very simple. You would use the same process on this next problem. The only difference is the numbers are larger, so if you don't know your facts, you might have to do some extra work on the side. The top part, 8 times 3, is a fact you should know. 8 times 3 is 24. However, the bottom, with the denominators, has larger numbers. If you haven't quite mastered your 12 table yet, you may not be able to quickly recall 12 times 4. If not, you just can quickly do the work on the side of your paper or pad to figure out that 12 times 4 is 48. Even if you have to do a little extra work, it's still quite simple since you do not have to figure out common denominators before you multiply. Here is one more example. 9 times 4 is 36. 4 times 3 is 12. you'll notice our answer is an improper fraction. Usually when we have improper fractions, we'll want to convert them to a mixed number before finishing our problem. Since we already know how to do this, this is an easy step. Looking at the bottom, I can ask myself, how many times does 12, the denominator, go into 36? I know that 12 times 3 equals 36. It goes in equally with nothing left over. So my answer, instead of 36 twelfths, is simply the whole number 3. If you would leave the answer like this, that's still the correct answer. You may just not get full credit for not converting it. So far, you're probably thinking that multiplying fractions is a breeze, and for the most part it is. But what if you come across a problem that has mixed numbers instead of improper fractions? Most times students would look at this for the first time and say, well, it's still pretty easy. 2 times 1 is 2, and then you do the same with the numerator and denominator. If it were that easy, that would be great. However, there are a few more steps involved. There are 2 ways you could do this problem. I think generally the easier thing to do is to first convert them into improper fractions. So let's start with the 2 1/4. My denominator stays the same. 4 times 2 is 8, plus 1 is 9. Again, my denominator stays the same. 3 times 1 is 3, plus 1 is 4. Now, again, I have a simple multiplication problem to do. And of course, you would want to convert it at the end. If you decided not to convert them into improper fractions, there is another way to do it. It may seem that this way involves a lot more steps, and it does, but depending on what kind of numbers your fractions has, say it has larger numbers, this way may still save you more time. So before we said that it would be quite easy if we could just multiply the whole numbers and multiply the fractions. It's not quite that easy, but if you remember a few steps, it still can be simple. You do multiply the whole numbers, but you also have to take each whole number times the fraction. So I like to draw arrows to help me keep organized with what I all have to multiply. I have 4 arrows, which basically gives me 4 problems. Let's start with the first. The whole number 2 times the whole number 1. 2 times 1 is 2. Next I have the whole number 2 times the 1/3. 2 times 1/3. Notice I now have a whole number and a fraction, but I can make any whole number a fraction by just adding a 1 as the denominator, and it's the same value. So 2 times 1 is 2, 1 times 3 is 3. Okay, now moving to the top strand, I have the 1/4 times the 1/3, and it doesn't matter what order you do these in as long as you get them all. And lastly, 1/4 times 1. And I'll just add that 1 to keep it a fraction. So now what I'm left with is a series of whole numbers and fractions that I have to add. So it is quite a bit more steps than the other method. So you just need to figure out what method works best for you. I'm actually going to start my problem over here so I can keep it lined up and organized. So I'm still not finished yet because I have to make common denominators. I recognize that all of these numbers go into 12. To get from 3 to 12, take them both times 4. This one will stay the same. To get from 4 to 12, and take them both times 3. Now I'm finally ready to add. My whole number will stay the same. My denominator is 12. 8 plus 1 plus 3 equals 12. 2 and 12 twelves is equivalent to 3. So like I said, this method has many more steps, and if you don't keep your work organized, you may run into problems. So it's important for you to just decide which method works best for you. I will leave you with these 3 problems to bring with you to class tomorrow. The first 2 are the first type we talked about. Just multiply straight across to get your new numerator and denominator. The third one has the mixed numbers. I would suggest moving them to improper fractions. That would be the easiest way to do this problem. In the next few days, we will have more practice with these and more time to go over the second method that has the multiple steps. If you're feeling confident in that method already, please go ahead and do it and remember to show your work. See you tomorrow. Please remember that you can review this video as many times as you need to see these problems modeled for you. These are the standards that fit into the Common Core for this unit. Remember, as we get to the end of this unit on fractions, these are the standards we are hoping to master. So it's important that if you still have questions on how to do these problems, you review the necessary videos.